Hi, everybody. Um, we are going into the next section of this unit. We're kind of closing up nuclear. I be able to do some sort of question and answer. I haven't quite figured it out yet. So we're going to move on to renewable energy and conservation. You guys are going to have a quiz at the end of this. It's going to be um, open-ended kind of stuff, like FRQ kind of things because that's what the AP exam is going to be. So I know we've done a lot of FRQs, and I kind of feel like that's paying off because that's all you have for the AP exam if you're still going to take it. Okay. So here we go. Hide that. All right. So renewable energy. Do you remember when we were watching the documentary on power, they went a bit into renewables and they went to this big solar bank, and I guess it was Japan, and they said that it was awesome and amazing, but the thing is that they were using all of these little like Apple phone batteries and putting them into these bigger banks. So the biggest issue that we have with renewable energy is solar, wind, things like that. When the wind stops, it doesn't generate the electricity. When the sun sets, it doesn't generate that electricity. So we need to be able to store that electricity in order to use it at a later time. Okay. So that's where we're kind of lacking in the field. But we're going to go over wind energy and a bit over the general renewable energy resources today. Okay. So there's a focus on the production of renewable energy. And if you guys haven't seen actually, um, during the whole coronavirus thing now, you're seeing air pollution with people on lockdown for the first time like ever in China. Their air pollution levels have gone down. The same thing in Italy. All of these clouds of smog have gone down. Our gas prices are like $2 and change, somebody was saying today. Because we're not using those resources. We've cut down on fossil fuels so much. So with renewable energy resources, those are things like hydroelectric power, wind, solar, geothermal, and wave power. And then there are a couple other like ocean thermal energy conversion and solar ponds. But what you really need to know is hydroelectric, wind, solar, geothermal, a little bit of the wave kind of stuff. Okay. Oh, and biofuels. How could I forget about them? Biofuels are anything that you burn, like wood is a biofuel. It's a renewable resource, depending on how you use it. Think back to the Lorax. Okay. Also, cow poop can be used. Remnants of, um, it's called bagasse. It's the remnants of cane, um, cane sugar. Like you take the sugar out of the sugar cane, and then you're left with this stuff, and you can burn it for energy. Okay. So, advantages. It's little local or global environmental long-term effect, but like solar panels, we don't make them in the US because they're not very environmentally friendly to make. Once established, you have very little input that's needed to keep these systems running, which sometimes is why we don't want them because they're only going to provide jobs to install them. And then you have the maintenance that's very, few and far between kind of things. They can be scaled up or scaled down as needed, and they can provide limitless energy. The sun isn't going to stop shining, the wind isn't going to stop blowing. Okay, the tides are going to keep going. So, disadvantages are there are high setup costs, just like with almost any type of energy. There's a lot of environmental damage in the short term, but then usually it does bounce back. Like solar panels, you have a field, and what now happens is you get you change the habitat of the area. A lot of technologies are inefficient. They're becoming way more efficient. Solar panels used to be only like 2% efficient, and now they're 24% efficient last time, which is really amazing news. And different energy supplies are needed for different applications. You can't put solar energy in your car, okay? But if you have an electric car, you can plug it into an outlet, and hopefully your solar panels will end up powering your solar car, electric car. So we have wind power, wave and tidal power, solar panels, hydroelectric power, which we've already gone over. Okay. But globally, hydroelectricity provides about 20% of the world's electrical demands. And here are well, let's go back, 10 major hydroelectric dams. You know, the Three Gorges Dam, the largest. The Grand Coulee Dam is up on the Columbia River. And, you look around, a couple of them in Russia. All right. So with hydroelectric power, we do have a decent amount of dams, but as you guys know, we don't want to dam up all our rivers, and the U.S. Army Corps of Engineers is saying, no more. We're not building any more big dams. Okay. You remember how hydroelectricity works. You have the water in the reservoir behind it. And then what happens is with any type of energy, not any type, okay, but most of them are, you want to turn that turbine. So coal, oil, natural gas, nuclear, okay, you heat up water to create steam. The steam turns the turbine turns the generator, generator generates electricity. With hydroelectric power, it's just the water that spins that turbine. Okay. The further the water falls, the greater its volume, the bigger the turbine and the generator can be. Okay, so here we go. Your water comes in. Oh, let's do some red. It comes in up here. It flows in through the dam and it hits this turbine and it just goes, it spins that turbine and it shoots out the bottom. That's it. So this turbine here then turns the generator. The generator generates electricity and then it goes out on the grid. Okay. Transformer, reservoir, penstock. You don't need to know the specifics. Okay. So with hydroelectric power, you have a high net energy. It is very efficient, long lifespan, and all of those amazing things that we learned about dams. You've got flood control downstream, you've got recreation upstream, you have a solid source of irrigation water and drinking water. But high construction costs. Dams are really expensive and they take a long time to build. You have environmental impacts. Those fish can't swim upstream. High carbon dioxide production from the reservoir, because now what you've done is you've taken productive land and you've flooded it. So then you get anaerobic conditions and you get a lot of carbon dioxide production from that reservoir. Okay. All right. Wind. I love wind power, wind turbines. So the United States, this is outdated. It's from like 2000. Here we go, 2011. We have an insane like capacity for wind farms. But there are some hiccups with them as well. Okay. So in North America, where's the graph that I'm looking for? I guess we'll get to it. So wind speed is relatively constant. You need these areas. So the tops of ridges, coastal sites, wide open plains, and they need to be really, really big. These wind turbines are massive. They're absolutely massive. They're like the size of a school bus plus. Okay. Um, these are also outdated. Okay. So inside a wind turbine, what you have is the wind catches the blades. And this, if this is there we go. Oh my God, it's the other way. So if this is your wind turbine like this, what's going to happen is they actually will rotate to where the wind is coming from so that they can actually spin. So here what happens is the wind turns the turbine. Why isn't this working? There we go. So the wind turns the turbine and then this shaft spins. And this shaft then spins to a smaller cog, and that is what turns the generator. So you get it to the rotational speed that you need to then to generate that electricity. Okay, so adjustable blades, the gearbox, it maintains the rotation speed so that it doesn't go nuts, and that's the generator there. So literally every single wind turbine, oh, yaw, see the gear, that's what I was saying. That's the yaw, okay, going back and forth. But the thing is that this is this generator here, and I'm pointing at it, you guys can't see. Okay, this generator here is generating electricity. So every single wind turbine is generating electricity. And then that electricity flows down through wires, down through the bottom of the wind turbine, and it goes into whatever grid system that that's connected to. So every single wind turbine is its own little power plant. They're amazing. Okay. So wind power, no emissions, little effect on land. It really doesn't disrupt them. It's a very small footprint. They can be located in a lot of areas like sea, very compact, quick construction. However, they do produce visual and noise pollution. Trump had said last year that we can't do wind power because the noise pollution causes cancer, which is not true. But there is a certain like whir to it. They do require steady winds, and you need backup systems because there isn't going to be wind there all the time. And it can interfere with the flight patterns of flying animals. Okay. Migratory birds, this is an issue, especially when they're offshore. Okay. But the Saudi Arabia of wind power is North Dakota, South Dakota, Kansas, and Texas. Texas has an insane amount of wind energy, which is weird because Texas is also the biggest place for oil, and it has a huge amount of solar. So there is so much possibility when it comes to wind power. And this is where we have really awesome potential. So if you see New Jersey here, you have pink, purple, and then red. So pink is good, purple is excellent, and red is outstanding. So a lot of these areas that are offshore in the middle of the Great Lakes, you can go a couple miles out and have these wind farms and create an insane amount of electricity. Okay, look at on the West Coast. This blue, superb. Now we're gonna watch some videos. All right, so the Atlantic County. Where'd it go? Here. Here we go. Atlantic County Wind Farm. Okay, this is drone footage. Let's get some fun music. Oh, I can't do full screen? That's stupid. But the Atlantic County Utility Authority is a sewage treatment plant, which isn't on the AP exam now. They cut that out. But I'm really glad that you guys know what happens to your poop when you flush a toilet, personally. But you can see Atlantic City here in the background, and they have 5 wind turbines, and they also have solar panels, and they're completely off the grid. So those are all of their solar panels. And then with the giant wind turbines, oh, there you go, secondary treatment that you don't need to put. It's really amazing what they've done here. And these were installed in like 2013 or something like that. So they've been around for a while. And here is the other one that I want to show you guys. This is kind of like the worst thing that can happen with a wind turbine. Um, if there are high winds, what happens is there's a break, and because you don't want it to spin too fast, because then this is what happens. They can catch on fire, and then those blades. Imagine if this was in a more residential area, you don't want those flying flames of blades everywhere. But what happens is in really high wind speeds, that brake will come on, it'll stop the turbine. And what even happens is the blades will all collapse in, and that's it. You just can't generate electricity like during a storm. It's too dangerous. Okay. So that's it for me for now. Um, if you want to go down the YouTube rabbit hole of flaming wind turbines, there are a lot of them. All right. I'll see you guys. Oh, look, there's a handy dandy screen down here.